thank you very much for joining. I'll just give a very brief introduction here. So Utkarsh will be sharing his work on Python and Flutter in the application of coloring and enhancing old photos. A little bit of a background. I see from your webpage that you're an aspiring ML researcher, but it looks like you actually are a ML researcher. So you might want to update that. Looks great. Looking forward to your session. So please go ahead.
Okay, thank you. So I will be starting. So my talk, the title of my talk is Python and Flutter applications for coloring and enhancing old photos. And in this talk, I would be like, I just developed a product in using Flutter application, and I use Python I use Python libraries to make to convert those old and black and white images to colored ones. And as these softwares are most of the times, even if we get these kinds of software, we have they are kind of costly, right? So I try to provide it in a free way and even in usable manner. Like most of the people use applications or what can I say, mobile apps, right? So so I developed a product using Flutter. It's through a Android mobile application through which anyone can upload a photo and they can get a colored photo in return. Okay, so I will just be so about me. I am a recent graduate and a machine learning developer at Quell Infotech. It's a RPA based company in India, and my major technical skills are in the field of machine learning, deep learning, and those Flutter app development and those data analytics. Okay, so basically what first of all, the first question rises here is, what are photos? So basically the photo are some kind of images. In computer science, we think of them as images, and I can express them as some kind of an external form or a person from the past. Like we generally capture photos to remember someone or some kind of special moment from the past, right? It kind of communicates some past incidents to us. So then what are black and white photos? Especially these black and white photos, more before these colored photos, we have black and white photos, right? And those black and white photos, we only have a single gray color channel. And I sometimes feel like they are less realistic, and they have subtleness in them, but they don't express reality in better form than colored ones, right? So in traditional manners, these images, these black and white images, can be converted to colored ones. First is the most used manner by hand, and secondly, we can use computers for that using Adobe Photoshop. But in both these manners, we do them by we require manual intervention, right? So the most important question that rises just now is, why do we need machine learning for this stuff? We already have two ways to do the same thing. Why do we need machine learning for that? So we need machine learning because these processes are time consuming. Even if we do the same thing by hand or by Adobe Photoshop, we require a lot of time, and it's also requires some person intervention, or we can use to say labor intensive process. So basically by the machine learning, we can just reduce the image coloring to a matter of seconds or minutes. Okay, so basically I just provided a API flowchart. I just used a Flask API for the thing for correcting it with Flutter application, and this is API flowchart. So I will just be starting by giving introduction related to the examples and the fields that I have used in building the product. So first of all, a difference. I would be telling you about deep learning. So the difference between an AI, ML, and deep learning. So basically the AI is for the computers. In AI, we try to make computers so that they can mimic human or brain activities. In AI, we try to create a complete human most of the time, right? But whereas in machine learning, AI is kind of we can say AI generally consists of conceptual things, not practical implementation. So in machine learning, it's kind of a subset for AI only. We try to create some techniques or like some methods, mathematical calculations, programs, so that we can so that a computer can uh, compute some things and can classify or can try or can mimic human activities. Okay, so what is the difference then? What's the difference between AI, machine learning and deep learning? So mainly deep learning is kind of a subset of machine learning only, right? So in deep learning, we generally deals with non-structured kind of data. So unstructured kind of data. Unstructured means related to images, audios, speech, text, those kinds of data. So we try to compute or like solve more complex forms of data with the help of deep learning. So next is our CNN. Okay, so it's CNN or convolution neural network. We can also call it ConNet. They are mostly used for analyzing images, or we can also analyze audio data, text data using the spectrograms. Okay, so basically we try to extract feature maps or data from the images by performing some sequence of convolutions or pooling operations. So first of all, in the images concept, we come across a term called as kernels. So basically, kernels are kind of small filters. We can call them convolutional matrix filters. Okay, so they are basically used for blurring out, sharpening, and processing, like we can say image processing techniques. So they do all these things, these kernels. We perform some operation called as convolution operation to find the blurriness, the sharpness, embossment, edge detection, and those kinds of stuff. So the next thing is like we have generally two kinds of operations in CNN. It's called convolution and pooling. Basically, we have these two kinds of layers: convolution layer and a pooling layer. Okay, so basically, I have also added an example for to write the code of convolution layer and the max pooling layer in TensorFlow. So first of all, what is a convolution operation? So basically, a convolution is kind of a simple filter. It tries to I would say it basically tries to multiply the individual elements with their filter, with the individual elements of the filter, and then sum them up to create some to extract some kind of data from it. So basically, by applying convolution operation again and again to the same image by using same kind of filter or like different kinds of filter, we can extract some important features from that image. We can also call that output or that features as feature maps. So this is an example of how can we use the convolution layer in TensorFlow. We basically use, I just gave an example from Keras. So the Keras, in that example, the Keras uses TensorFlow as backend. So in Keras, there is a class called as layer, and that class layers we have a there is a subfile called as layer. In that subfile, we have a class known as con2d. So in the con2d, we can perform these operations. First is the number of filters. Second is first parameter is the number of filters. Second parameter is the size of the kernel. So in this example, we have given the size as 3,3, right? And the padding, there are like many different operations. And the max pooling is kind of we can say max pooling is kind of a downsampling of the feature map. So we try to reduce the size of the image by by reducing the size of the image, we can reduce the number of parameters, as well as we can extract the important feature maps, not the irregular ones. So basically, the pooling operations we have, there are two kinds of poolings, like is max pooling and an average pooling. So in the pooling operation also, we have the same things from keras.layers dot average pooling 2D and max pooling 2D. So I have also used an add layer. Add layer generally does add layer just add two matrices of same size. Okay. So next is an important concept of an autoencoder. So an autoencoder is a kind of an artificial neural network, you can say, which tries to learn data from by compressing it. So an autoencoder is basically consists of contains three parts. First is an encoder portion, a decoder portion, and a bottleneck portion. Okay, so in the encoder portion, we tries to compress or extract features from the image. In the bottleneck portion, we add some like full, we can say FCNN or some dense layers, and then in the decoder portion, we try to recreate that same image. Okay, so basically it learns data by compressing it in the encoder portion. In the bottleneck portion, it processes it to extract the important features or to learn it, and in the decoder portion, it tries to recreate it. Next, this is encode of an autoencoder portion. Sorry. Okay, so basically there are like different types of autoencoders, like denoising autoencoder, sparse autoencoder, deep autoencoder, convolutional autoencoder, variation autoencoders. Okay, so in my project, I just use convolutional autoencoder because I'm like in this product we are we are just compressing the image, a black and white image, and then trying to recreate a colored image, right? So I have used an convolutional autoencoder. In that, I have also used skip connections. So mostly neural networks or the large neural networks suffer from a problem called as degradation problem. So in degradation problem, whenever the depth of the network increases, the gradient parameters become so small that that even multiplying or squaring them gives nominal, or like I can say no changes, right? So we generally use skip connections. This concept was used in Resonate, that was given by Microsoft. So basically, these autoencoders, the convolutional autoencoders, I would say, have convolutional and deconvolutional layers, right? So they also suffer from the problem of degradation. So most of the time when we like decompress the image and then recreate it, it may happen that the important features or the information that image contains, like if an image contains a cloud or a tree, that information might get lost. So to improve that, I have used skip connection, and these skip connections are from a convolutional layer to a deconvolutional layer, or I would say from an encoder, part of an encoder to the part of a decoder. It's skipping over the bottleneck section. So I'm just sending the feature from a convolutional section to a deconvolutional section, so that even if an information get lost, it can be created in the further layers. So I have come again to this API flowchart. So in the API flowchart, I have also used, like I told you about the model prediction thing. So my model architecture looks kind of similar to this because this is a unit architecture. So I consecutively use 3 convolution layers and then a max pooling layer to reduce the parameters and just take the important parameters into account. In those convolution layers also, the 2 subsequent layers are like have exactly same things, and even the padding are same. So the image is not even resized, like it's not even like the image size does not even change. In the next layer, I've increased the number of filters so that even after two convolution, the number of the number of important feature maps we have might increase to the in the third layer, so that we can get the features in depth. So that was the encoder section. This is the decoder section where I try to like upsample the images and recreate it. So first I have used the upsampling one. So I have increased the image size by upsampling it. Then I have used that skip connection, and in the skip connection I have used the add layer. So the feature map from the convolutional from the encoder section is transferred to the decoder section and is being added so that the features can be retained. Then I use like 2 or 3 convolution layers, and then this function is being repeated again and again. Then after these 3 convolution layers, the upsampling is being called again. Then the same add function of the skip connection, and then 3 convolution, then upsampling, and the same process happens again and again. So I've used 2 other functionalities in the API. There's like gamma correction and a super image resolution. So I have used in a gamma correction here. So most of the times when we give some kind of an images, we might encounter images that are like very dark, right? So to reduce the image darkness, I have used gamma correction. So gamma correction tries to control the brightness, overall brightness of the image. Okay, so by varying the amount of gamma, we can change the brightness of the image, and we can also say it changes the ratio, the color ratios of the 3 images, like the color ratios of RGB channel. This is an example of gamma correction code. Next, in the flowchart, I've used super image resolution also, because most of the time the older images that if we click or we have are like small, very small images, like 200 to 200 pixels. So those photos might, if you want to if you want to use those photos somewhere, we might be requiring them to have like around 2000 pixels, right? So I have also added the super image resolution so that the model can so that the image that we receive from the model is of a fixed level pixel, so that even if we have to use it somewhere else, it won't be a problem. So basically in the super image resolution, these are like some sets of algorithms and techniques to increase the size of the image, or like upsampling the image, upsampling the image, and also keeping the resolution as same. So if I need to take like if I put it more simply, uh, if we increase the image from its height or width, the degradation in the image won't there won't be any degradation in the quality of the image. So the next is an API. I will just discuss about an API. So basically, it's an API is kind of an intermediary software that allows communication between 2 applications. It kind of acts as a gateway that allows these backend softwares or servers to communicate with them. Okay, so most of the times we have this we use these weather apps, right? So these weather apps generally contains these APIs or some other things to get us like weather. Even we can say these APIs are used to like in the chatting applications and Facebook, or like weather applications, instant messaging, DMs. We can use APIs. Okay, so there are like different kinds of frameworks in Python. I only use the Flask one. So this is like a basic code for the Flask, and like a small code where we need to like create an object of the class Flask ask, and I have given debug equals to false. That means even if we run the code, if we changes the code, if we even change the code, we have to run the server again. So this is a small example. Next, for the production purpose, I have used the Flutter application. So it's like the most advantage. There are like many advantages of Flutter. So first of all, it has beautiful UI. It's productive. It is very fast, and it's open source. I will just be explaining. telling you about those. So basically, this Flutter is an expressive and has beautiful UIs. It has many built-in material apps, designs. Even it has Cupid images. I would say these Cupid images are used in iOS applications. So it has motion-rich APIs and natural scrolling and many other things. So it has reproduction and native performance. So so in the application, they're like in the application we have a natural kind of scrolling. We have scrolling. We have different kinds of scrolling. We have different kinds of icons and fonts and navigations for different platforms. That's very fast. I would say very fast for development. So because Flutter has two important things called as hot reload and hot restart. Like if I'm like developing an application and I'm running my application on my mobile device, if I even do some changes and if I just save it, the changes would be shown in the UI in a matter of seconds. Even if we hot restart it, all the changes, even the files in code or even there's a kind of error, those error might be resolved in hot restart. It also helps it helps in quick implementation of UI features and also helps in fixing the bugs faster. And the most important thing, just like Flutter, Flutter is just like Python. Flutter is open source and it's freely available and has like thousands of in Python we have packages, right? So in Flutter we have plugins. Like there are thousands of plugins for UIs, backends, and other things. So what kind of language do we need? So Flutter basically uses Dart language, and this language is kind of similar to Java. The platform availability, most important thing, it's native, and we can build a same Python code can be run for both Android and iOS for creating websites. The same code can be used in desktop. Even for I would not say desktop, just a desktop. I can say all the three types of computer versions, like on the Linux, Mac OS, or the Windows. And recently, it has stepped in embedded system also. So this is a small sample code for like designing like there's a main class. We use an app function to call the main class. They're like themes, material app. This material builds the whole application, and here we have a scaffold. So the scaffold is like a complete first page, like a complete page. And the complete page we have the app bar. The app bar is the top app bar in the blue color. We have the welcome to Flutter written inside it, and the like center widget. The basically in the Flutter we have something called as widgets, and they're like state. There are two kinds of states, like stateless and stateful. There are many different concepts. So a small application demo. I will just go on and show it to you. So this is my application. You can just select images from camera or from the gallery. You just have to select it. This is a crop section. If you want to take the complete image or if you want to crop it, then there is a small confirmation screen. Do you want to crop it back, like, or like you want to continue with the images? If you continue it, there's a small loading. This is the most time-taking process because the image has been uploaded to the API. Then the model processes the 2 or 3 steps, and then the image is being sent back. And the image is around like I would say more than 1,000 pixels around. Okay, so thank you.
Thank you very much, Utkarsh. So do we have any questions? Sorry, I'm just looking now in the Q&A. So we have a question from Eugenio. So just to clarify, where does the Python code run?
The Python code is running on it's a Flask API. So it's being deployed on the Heroku. And I would say it's running on a remote server. Mostly a Linux-based server.
Okay, great. Any other questions for Utkarsh? Well, I guess you covered everything in your presentation. That was really interesting. Oh, another question here. Is the code available on GitHub? Yes, super important.
Just now the code is not available on the GitHub. Like I have all the code has been available on the GitHub, but it's a private repository. So, and it is also some kind of project, my personal project. So I cannot just go on and available give you all the code. And I'm like thinking about changing the repository from private to public. It might be happening in like around 1 or 2 months. Let me see, because I am not the only one who has worked on this project. Like they were like 1 or 2 of my friends also. I need their consideration.
Okay, well, we certainly hope to see more of that then in future, and hopefully open up that repo. Well, I think let's close up your session now, Utkarsh, and if there's any additional questions, you can take it up with Utkarsh over Slack or other means. So thank you very much.
Thank you.